conversation. I want to thank you both immensely for taking time out of your evening with your family and things like that to join me here on Drinks at the Forefront of IoT. Before we really get into the meat of the conversation, I want to hear about ChemImage, because I think that you guys are not a lot of people, especially in our area, really know who you guys are, and more importantly, like what you guys do. I think it's super fascinating. Let's kind of dig into some background. And before we do that, are you guys drinking with me? Am I drinking on my own?
Cheers.
All right. Yes. What do you guys have?
Miller Lite.
So since it's September and it's the official, unofficial start of fall, I have some Down East pumpkin cider.
Yes.
Nice.
That is awesome. Good for you. I have not dabbled into the pumpkin beer yet, but I wanted to this morning when it was 52 degrees when I woke up.
It's life-changing, I have to say that. And I'm not sponsored by Down East, so.
Well, maybe you will be. Maybe after this, they'll maybe they'll do some. I'm doing some Voodoo Ranger. I actually think I'm going to switch out to a hitchhiker, one of our local. Have you guys had any hitchhiker?
I have not.
No, they've got one up north, and then they've got one in Mount Lebanon. Really great if you guys have an opportunity to check it out. So let me get this in here. We'll do a little cheers, and then we'll get into the background with you guys. So all right, here we go. Cheers, guys. Thank you so much. Appreciate y'all.
Cheers. Thanks for having us.
Thank you.
Awesome. So who wants to kick us off? Becca, Matt, who wants to kind of share a little bit of your background individually?
Well, I think Matt's going to kick you off.
Yeah, I'll introduce myself real quick, and Becca, you can do the same, and then I'll jump into who ChemImage is and what we do.
Perfect.
So I'm Matt Nelson. I'm an analytical chemist by training. I'm the CTO at ChemImage. I've been here for going on 23 years. So my responsibilities for the company are primarily around the research and development activities. There's two core groups within the company that I oversee. One is the life sciences group, and the other is the sensor systems group. And that also includes our hardware engineering team. So we are primarily responsible for a lot of not only the R&D activities, but the testing activities around the development of our products that we sell to customers, as well as the project work that we do for various partners and government entities. Becca?
Yeah, so my name is Rebecca Schuler. I am a senior product manager at ChemImage. My background is chemistry. I started work at ChemImage almost 20 years ago. And when I started as an entry-level scientist. I did that for several years, then moved into proposal management, and from there moved into product management. So now I'm responsible for the sensor systems line of business, the products associated with that. So we have a few products and a service offering for that line of business. The VeriVision Mail Screener is a system for detecting drugs concealed in mail sent to inmates. We have our VeriVision Threat Detector, which is a system that's designed to detect explosive residue on surfaces at a standoff distance. And then we have our vehicle screening service that utilizes the VeriVision Threat Detector. And that's something that we would take to special events and supplement a security team to scan vehicles at entry control points.
Super fascinating. Just incredible. And I want you guys to get into kind of the hows and the whys. But for each one of you individually, and Matt, we'll start with you, and then Becca will go with you. What drove you to where you are today? Like how did that come about? What drew you to the chemistry? the science behind, and then the detection of the bomb residues, and now the drugs in the letters and stuff going to the prisons.
Yeah, so with ChemImage is now about a 27-year-old company. It was founded in 1994. Over the years, the technology has been demonstrated to be adaptable to so many things, which makes this job really exciting because it's always something new. There's new applications of the technology, far beyond what we would imagine just years ago, and what we're able to do with what we've got. So over the years, it has gone from starting out in semiconductor characterization, then moved on to pharmaceutical applications. After 9/11, there was a lot of discovery in terms of what the technology could do for various types of threats, starting out with biological threats and thinking back to the days where we had the anthrax scares. Then that migrated into standoff detection of explosives and narcotics for military and law enforcement applications. And more recently, we've been doing a lot of work with medical applications, assisting surgeons with surgeries or endoscopic applications where you take the technology into the body. So it's just all over the place. So the things that drive me personally, things that drive the company are these applications and needs that are out there that the technology can address.
That's awesome. Becca, anything to add to that? How does this, how are you driven by this?
Yeah. So what initially drew me to ChemImage, so when I was in college, I had started as a chemical engineering major and decided that probably wasn't for me. And while I was there, I decided I wanted to get into forensic science. I thought, that's when forensic science was really starting to boom, when, those forensic files shows were on and things like that. And I thought, yeah, that's really what I want to get into. And not a lot of colleges at that time had specific forensic science majors. So a lot of it was, get your chemistry degree and then you can go be a forensic scientist. So that was my plan. And at one point in my college career, I did a paper on Raman spectroscopy and how Raman spectroscopy could be applied to forensic science. And that's sort of how I became aware of ChemImage, because ChemImage was doing a lot of Raman spectroscopy, Raman molecular chemical imaging. And at the time, they also had a forensic science offering where we were using the technology in forensics applications, but there was also a forensic scientist doing casework at ChemImage at the time. And that's how I sort of got started there at ChemImage. And it just sort of grew from there.
It's awesome. You guys are in kind of this space coming from a chemical, like a chemistry background, both of you from a science background, and kind of filtering now into technology, right? And I guess not now. I mean, how many years would you say that ChemImage has really been kind of circling or in and developing in the IoT space with the products that you guys are developing?
Yeah, so I think it's been progressing for quite a few years. We've been working in what I would call the IoT space, or awareness of things space, which is related to IoT, and I think Becca might want to spend a little bit of time explaining that. But we've been doing that for the last 5 to 10 years at various levels, and we have a spin-off company called Endoscopies, which I believe is going to be highlighted on one of the podcasts here in the future. A little plug in there for them, but that's what their focus is. And so, it's been coming for several years now, and it's really at the forefront of what we do.
That's awesome. Becca, do you want to touch on the awareness of things that Matt mentioned?
Yeah, so I would say that our spin on the Internet of Things is what we call the awareness of things, and it sort of takes the Internet of Things to the next level. So we know that the Internet of Things is based on smart technology, connected devices, and it allows, say, for example, your refrigerator. If you have a smart refrigerator, it can tell you if you're out of milk and send a message to your smartphone so that you can stop for milk on the way home. Or better yet, it can send a message to Target to order milk for you so you can just, pick it up. The awareness of things sort of takes it to the next level, where it allows us to aggregate all the information that's generated from these smart sensors and perform an analysis on them so that we can determine trends at an enterprise scale, essentially. So, I had talked about our VeriVision mail screener, and this is one, really great example. So the mail screener is a system. It's used in correctional facilities to scan incoming inmate mail and detect drugs that people on the outside are trying to smuggle into inmates in the correctional facilities. So every time there's a detection of an illicit substance, the officers, the corrections officers or the mailroom staff get actionable intelligence. So they're able to interdict that illicit substance. They're able to confiscate the mail. But at the same time, all that information is stored and aggregated from our facilities around the country. And then we can use that information from all over the country to essentially determine drug trends in the nation. So that's sort of where we're coming from with the awareness of things.
Wow, man, that's absolutely fascinating. So are you guys able to talk about how the technology works? Because when you're talking about, I understand it, right? I understand that you have something that visualizes or scans or alerts of some sort of an explosive residue or some sort of drug residue in the body, the things that you guys are looking for. Can you walk me through, without giving away the secret sauce, but walk me through like how the technology works? What kind of IoT components are in here? Just kind of give us a peek under the hood a little bit.
Sure. So I could take a stab at that. So, everything that ChemImage does has to do with molecular chemical imaging. So molecular chemical imaging basically combines the spectroscopic measurements that can be taken on materials. And that really has to do with how matter interacts with light, and combining that with an imaging modality. So in this case, we're talking about digital cameras and coupling technologies that can look at individual wavelengths or colors of light. So how it works is most of our technologies have a liquid crystal based device inside, which allows us to look at certain parts of the spectrum. So it's not too different than what you have in your some of your TVs that are out there, the liquid crystal based TVs that have these materials inside them. You apply voltages to the device, and it allows certain wavelengths to pass and certain wavelengths that are blocked. So what we've done over the years is developed a lot of know-how and capability from a hardware, software, and algorithm perspective around these devices, so that we can carefully control them to adapt to the needs of the different application spaces that we work in. So in the case of an explosive detection, what we can do is take these filters and tune them to the specific signatures that an explosive would have, and look just for that signature. And we have the ability to search against a library of signatures in a way that it can come back and say, well, you've got explosive X or explosive Y. And that's the same approach that we take whether we're talking about explosives or drugs or chemical agents or medical applications. Maybe it's cancer or some other application of the technology. There's so many molecules that are out there that have signatures that we can tap into with the technology and make an indication of what's there, how much is there, how it's distributed spatially, and that's the information that we are tapping into when we use our technology.
That's awesome. Do you guys feel like you're working in science fiction? Because it sounds like you're working in science fiction just a little bit. Like, I mean, it really is. It's mind-boggling stuff.
It is. You know, it's cutting edge. A lot of what we're doing is brand new, and you know, it's amazing how over time new applications come to us, or we come to the application based on what's going on in the market and understanding what the needs are. And it is a little bit like science fiction in some respects.
Oh, man, that's wild. So, so we've got the history. We talked about the awareness of things. Tell me some interesting facts, some fun facts about your technology that people don't know.
Do you want to start, Matt?
I can. I mean, I think some of the fun facts are the uses over the years that we've had. Yeah, there's a long laundry list. Becca's been involved in many of those. I've been involved in many of those. You know, I think some of the things that I remember most are, you know, after the 9/11 events, we started getting into some of the safety uses of the technology. So safety and health is really what ChemImage is all about. Those are the application spaces that we play in. So once we started to get into the standoff explosive detection work, that was really interesting to me. We were able to take the technology and integrate it into a number of the Department of Defense types of entities. And what we did was we started out by having standalone instruments that were developed to be able to be inserted into entry control checkpoints. So the idea is the vehicle would come through a checkpoint and the sensor would be looking for residues of explosives. And the idea is that if somebody was handling explosives, it's you know, the first law of forensics, there's going to be some transfer of that material from one surface to another. And if somebody's touching a door handle or a trunk or the gas cap or whatever it may be, we had the ability to not only sense that they've touched it, but where is it on the vehicle? And that information could be relayed to the people that were controlling the entry control points. And then there was a number of courses of action that would follow that. So we'd actually deploy
certain things that need to be done.
Absolutely. So we were fortunate enough to be able to deploy this to Afghanistan to help with the war effort. So it was over there for a number of years. There were interdictions as a result of our technology being there.
Wow.
You know, that's information that I can't expand on because it's classified, but there were interdictions that led to you know, preventing explosives from getting.
So lives were saved.
Lives were saved.
That's incredible.
Maybe Becca could talk about, you know, similar kind of thing with the mail screener and how that's saving lives.
Yeah. So like I said, you know, we have the VeriVision mail screener at correctional facilities across the country. I think we're up at over 70 correctional facilities at this point. And essentially, drugs, you know, in correctional facilities, they can cause a lot of problems. They contribute to gang violence. They contribute to unpredictable and sometimes aggressive inmate behavior, which endangers the lives of fellow inmates. It also endangers the lives of the correctional officers. So if we're able to do anything we can to prevent those drugs from getting into the facility, you know, that's what we want to do. And essentially the mail screener technology was developed from the technology that was used for the explosive detection, the standoff explosive detection. So, you know, essentially we developed algorithms and routines that were specifically designed to detect drugs as opposed to explosives. And what it can do is actually detect the drugs within mail items. So, criminals are very, very creative in the ways that they're smuggling drugs. So, you have an envelope, how the envelope has some seams in it. You can split those seams and put drugs in the seams and seal it back up. You can hide drugs under the stamp. If you have some sort of cardstock material, you can split that cardstock and put powder or even, some sort of solid drug in between the layers of cardstock and seal that back up. You can dissolve drugs in a solvent and spray that liquid onto the paper and allow it to dry. And in those situations, it is virtually undetectable with just regular visual or manual screening. The typical method that the mail inspectors use is they take the letter out of the envelope, they hold it up to the light and feel around it, and it's so easy to conceal the drugs such that they don't, even with they're very committed to what they're doing, and they're extremely diligent, but sometimes it's just very difficult to find that. So when you put the piece of mail onto the mail screener, our software and algorithms are able to detect if the drugs have been concealed there. And really that helps to cut down on all of those things that I talked about earlier, the inmate violence, the gang violence. I mean, if you take a single sheet of paper that has been soaked in methamphetamine, it can be worth thousands of dollars in jail. They'll take that paper, they'll cut it into 1-inch or 2-inch squares, and they'll sell it to all the other inmates. Or the synthetic cannabinoids now, that things that we know as K2 or spice, in conventional naming, and that they can cause real problems with people who use them. And even with the opioid crisis, we know now that fentanyl is in everything. Fentanyl's in heroin, fentanyl's even in cocaine. Why do you want to put fentanyl in cocaine? I don't know. But they're finding fentanyl in cocaine now. Sometimes even marijuana, which is mind-boggling to me.
Yeah.
And if you're a mail inspector and you open a letter that has fentanyl in it, even ingesting a small amount of that can, render you unconscious or even kill you in some instances. So that's really, really dangerous.
Wow.
And ultimately, that's what we're trying to prevent, is being able to detect those drugs before those incidents happen.
And I was going to say, it sounds like, that without your technology would be super challenging, because we're not, the advent of synthetic drugs, right? And like you said, like they're getting so creative in the way that they create and transport and take from one place to another, and can form these drugs in many different ways and shapes, right? You guys are actually detecting this on a molecular level. Like, am I correct in saying that? Like, you guys are able, even with the bomb detection and the residue, like, this is on a molecular level. So even if you clean and sanitize and wash off, the molecules that are in that substance are still there, correct?
Yeah.
That's correct.
Wow. It's just, it's still so crazy to me. That's awesome. Small tidbit. You talked about criminals getting creative. I actually started out very, very long time ago, my job careers as a loss prevention detective agent. And so I know firsthand how people can be very, very creative when doing something shady. All the different places that you can hide video games and tools. So yeah, I can only imagine what it's like, especially in those systems where there are large amounts of money on the outside trying to get that stuff in.
Yep.
Yeah. And the inmates, they're incarcerated 24 hours a day, 7 days a week. They have nothing better to do than to come up with ways to beat the system.
Yeah.
So, that's one of the things that we need to make sure that we are aware of is the trends and the new methods of concealment and the new drugs that are out there, so that, we're not constantly chasing the problem. We can head it off before it becomes a problem.
Yeah.
And
So
that's part of why that's part of why this awareness of things concept is so important. When the more of these instruments that we have out there, the more they're distributed, we could start to collect that data and understand what the trends are from the West Coast to the East Coast or wherever it may be, and learn from it. And other jails and prisons and their staff will learn from it as well, which is very valuable.
So safe to say, not only have you guys developed the technology to be able to view and figure out what kind of molecules are there, like what is there, you guys are running some pretty heavy data analytics on the back end to be able to track those trends and gather that information, display that information.
Absolutely.
And that's awesome. And I mean, they say, so I hear, my wife's in data. Data's the new oil, right?
It
That's
really
awesome.
is. Yeah.
Yeah, we have a pretty extensive team here at ChemImage that, from algorithm scientists to computer vision scientists to machine learning, deep learning scientists, modeling experts, a pretty extensive team. We have over 100 employees here, which I don't think I'll mention at this point. But most, I'd say, a good percentage of those have advanced degrees and a lot of, scientific backgrounds, which, they contribute to all the things that we do here. And software and algorithms is a critical component to what we do. And a lot of emphasis goes into that and into what we provide. That's really where the secret sauce is in what we do. Without that, there would be nothing. So yeah, that's a critical part of it all.
Yeah, man, that's wild. So we've talked about bomb detection. We've talked about mail detection. We've talked about a little bit of the health implications of what you guys do. Can you speak more into that? Like how you guys are using your technology in the life sciences space?
Sure. So there's a number of different application areas. One of the areas that we've been doing some recent work in is in the area of heart failure. So as you probably well know, heart failure is one of the leading causes of death. There's a lot of healthcare cost associated with heart failure, and some of the current care and procedures around heart failure are problematic. They're very subjective in the way measurements are done, and there's a lot of costs associated with rehospitalization of affected patients as they come back in after they've gone through sort of a spiral in terms of their condition. And so we've been working on a new device, which is based on molecular chemical imaging, which measures different levels of the heart failure in terms of their amount of hydration or amount of water that the body is retaining when they get into that condition. So when you get into congestive heart failure, you start to retain water. And what we're able to do is make some measurements on different parts of the body to understand what level of heart failure they're at. And we can do that in a way it's very objective and quantifiable and can be tracked by not only clinicians, but by patients themselves. So this is both for hospital use as well as home use. And so we're currently in a number of clinical trials where we're proving out the technology and looking for partnerships in this area that will help us move it forward to through FDA approval and then eventually selling this as a product in a couple of years down the road. So our early results are very promising. We're very excited about what we're seeing. We think we have a solution that's going to be game changing in that particular space.
That's awesome. I was going to say that FDA process is not something to balk at. It's a challenging process altogether.
It's a long road and lots of hurdles.
It is. So here's a great question, because I'm assuming there's others out there, but the challenge of going through DoD with a bomb detection versus the challenges of going through FDA approval, which is more difficult in your opinion, or are they both equal difficulty?
No, the FDA road is much more difficult. There's a lot more involved in getting that approval.
A lot more regulatory,
absolutely,
red tape. Interesting.
Yeah.
Man, that's awesome. All right, so I mean, that in and of itself is just fascinating. That you're eventually talking about some sort of an in-home device for folks to be able to kind of track this early onset, congenital heart failure, which is amazing. Because I mean, heart failure is one of the leading causes of death globally, right? Or am I misspeaking
Absolutely.
there? I may be misspeaking.
That's correct.
I oftentimes will throw out facts that aren't really facts. So if please correct me.
Yeah, you got it right.
Okay, awesome. So that's something that you're working on now. We've talked a little bit about the history of ChemImage, like how ChemImage came to be. We've talked about some of the real incredible milestones that you guys have, and this life sciences product is on the horizon. What's next? Like, what's the future for ChemImage? Where are you guys going?
Yeah, I think.
Are you going to the moon? Are you going to Mars? Is it going to be outer space stuff? I mean, what's happening next?
Well, in some respects, we've been to Mars. Funny you bring that up. You're asking about some interesting facts about ChemImage. So
yeah,
a number of years ago, there was a paper that came out in the publication Science, and it was around whether or not there's life on Mars. So there are meteorites that are being collected and still are being collected mainly out of Antarctica. So over time, there are meteorites that make their way from Mars all the way to Earth. And there's scientific ways to validate where it's come from. And they decide based on those measurements that it comes from Mars. So our founder and president, Pat Trito at the time, this was very early on in ChemImage's history, was asked to participate as a Raman expert on a panel which was looking at these Martian meteorites. And so he was fortunate enough to be able to get some samples of these and take a look at them with our technology at the time. And we were using a laser-based technology at the time called Raman spectroscopy and Raman imaging. And the idea is you shine a laser on the material, and based on its molecular makeup, there are different colors that come back off of the material at a color that's different than the laser that you're shining on the device on the sample. And so he looked at the meteorite, and he was looking for various types of things that they were interested in the time. I can tell you that he didn't find any Martians within the meteorite, and no specific evidence of life on Mars based on the measurements that were made. But it was an interesting tidbit, an interesting artifact to be able to look at with the technology, and he was able to contribute to that overall effort at that time.
That's awesome. Becca, anything to add? You're on a product front.
I am. I don't want to give too much away, but where I see the technology going is more of a consumer type of use, something that everyone can have it on their smartphone for a variety of applications, whether it's taking your phone to the grocery store and determining the ripeness of fruit or vegetables, to maybe looking at some questionable lesion on your skin. Is it skin cancer? Is it just a pimple? Something like that. Something that you can integrate with your smartphone and essentially use it home. That's really where I see this technology heading. Yeah.
So, I mean, like everything else, every other technology, shrinking down to let's have it in our pocket and have access to that. That sounds like real Star Trek stuff, though, right? Like them pulling out
the
the little.
tricorder.
Yep. That is awesome. That is awesome.
Yeah. Historically, we've done a lot where we've taken, some of the instruments that started out the size of a refrigerator, and we've been able to get it down to something that can be held in somebody's hand. And we've demonstrated our ability to do real-time imaging with it, which is a capability that these devices never had until a few years ago. So we found a way that we can make a small number of measurements very quickly. In fact, that the frame rates of these cameras, that gets us into applications where you have motion happening, whether the sample's moving or whether the sensor's moving or both are moving, and to be able to keep up with that and provide that chemical data that provides information for the application of interest. So we've been able to crack that egg in the last couple of years, and I really see that's where the future is. It's going to be these real-time devices that are either handheld or in surgical devices at the tip of an endoscope, or as Becca mentioned, in somebody's smartphone for consumer applications. It's just an endless list of possibilities.
It's all about just getting through those FDA approval processes. That's it.
Yep.
That's awesome. All right. I'm going through the list here, and there's a couple of things that I want to touch on. And you've got the Pittsburgh Steelers in here. What do you guys have? What's the deal with the Steelers? Since we're all in Pittsburgh.
So earlier I was talking about our product that we developed with Department of Defense funding, and it got deployed to Afghanistan. So after the withdrawal of troops several years back, and the technology was coming back, we went on and took the technology and what we learned from it and began to commercialize it. So that's one of the Vera Vision product family products that came out of that. And the idea was to take these very large military devices and reduce them down in size and make them portable and use them for other applications, and specifically around law enforcement. And there are a lot of applications even today where you have entry point control, whether it be a sporting event or a political event, or an important building that's being protected by a entry point checkpoint at the front of the building. And so we started once we had the technology into something that became commercial, we were able to take this out and demonstrate it as a service as part of our product offering. And we were fortunate enough to in the early parts of this to take it to some high profile events, things like the USGA, the Pittsburgh Steeler games, the Pittsburgh Marathon after the bombing in Boston several years back, the Macy's Thanksgiving Day Parade. It's been to Times Square. It's been to the Indianapolis 500. So all these high profile events, we've had an opportunity to take our equipment there and be part of the security detail as far as the screening vehicles as they come in to the checkpoints. So that's been pretty exciting.
It has to be. I mean, it's got to feel good too, right? Because there's a lot of things that you guys both could have done with your life. You're both seem like very smart individuals, right? And I mean, there's a lot of things that you could have gotten plugged into. This seems like with what you guys are doing, the safety and really saving lives behind the scenes that people would never know about, right? Your technology is meant to alert the people that can take out the threats without anybody that's at the event knowing that there was ever a threat there to begin with, right? And so, I mean, I commend both of you. I think that's pretty incredible to spend careers doing that.
Thank you. It's been a blessing. I mean, it's been some really cool stuff, some really neat adventures. As a chemistry major way back when, I never envisioned doing what I'm doing now. I mean, it's been amazing.
That's awesome. Becca, do you want to add something there?
Yeah, no, I was just going to talk about the I actually got to participate in the security screening for the Macy's Thanksgiving Day Parade. And I wanted to talk about, the dedication of the NYPD and all of the different groups that are involved in protecting the spectators. I mean, it's truly, we talk about the way our technology can detect these explosives, and honestly, it's fantastic technology. But there are several layers of security that have to be applied. Like, no technology is actually a silver bullet. There are layers upon layers upon layers that really no one is truly aware of, and we shouldn't be aware of all of those layers, because that just gives us a way to defeat those layers. But it's all of those layers combined that really help to protect the spectators and the participants of those events. And I will say, I worked alongside the NYPD group that was using the VeriVision threat detector. I was, there over Thanksgiving. My family came along, and they were at the parade. They went to see the parade, so we weren't, we were protecting them as well. And that just that, that was, we were blocks away. It's not like we were right up at the parade. Like you said, no one knew we were there. We were blocks away, just, scanning vehicles that were driving down the road, just making sure that everyone was safe. So it was definitely, an eye-opening experience, really humbling experience too. Especially, there were some instances, and I don't really want to get into too much of that detail, that it was a little bit tense. There were some questionable things that happened, but everyone handled it very professionally, and it was great.
Yeah, man, it's crazy. I think that talking about security, especially with the state of the world today, right? And we won't get into politics and whichever side or anything. Like, this is not a political webcast in any way, shape, or form. But I think we can all agree that stuff is happening in the world that 10 years ago, 20 years ago, like, we wouldn't really necessarily think about. And I think, like you said, there are several layers that apply. Like, if people really knew the level of security that was around them, we talk about Big Brother and stuff like that, but like, I mean, what else? Like, what else is there? There's a lot of ways that things can go down, and I think for the most part, by and large, at least here in the U.S., we've been able to minimize the amount of tragedies that happen because of things like that. And a lot of that has to do with those layers and the boots on the ground and police departments and organizations like ChemImage that are putting time, energy, lots of money into building solutions to make the world a safer place. And it's crazy once you really start thinking about that, So again, I think it's awesome. I think what you guys do is absolutely fantastic. Really excited to see like where you guys go in the future and what happens. I want to touch on two things before we wrap up. One, I want to give you guys an opportunity. You briefly plugged Inatescus. And I want to give you guys an opportunity to really talk about what Inatescus is, because you guys just launched back in June. Inatescus as a spinoff, and we do have plans with Chris on another podcast. I believe it's going to be either later on this month or sometime next month to be a guest on the show. But talk about Inatescus, and then let's talk about what if folks are listening and they're kind of in spheres of influence that are helpful and beneficial to you, where you guys are looking to go, like how people can help, what types of introductions make sense for you guys at this point in time in the business.
Sure, I'll take Inatescus if you want to take how people can help. So as far as Inatescus, I mentioned before, we have a very strong algorithm team, and a lot of what we do here involves machine learning and deep learning and some of these new artificial intelligence approaches to mining all this data that we collect. And one of the challenges that we have and others have is how do you train all that data in a way that you get meaningful information out of it? And our former director of software, Chris Anderson, who is now our CTO for Endoscopies, recognized an opportunity there and was able to, through a period of time and some planning, able to stand up what is now called Endoscopies, which is formally being spun off as a separate entity from ChemImage. And basically what they do is they have developed ways that facilitate ways of annotating the data, ways of telling what bits and pieces of the data are associated with the things that you're looking for. So that might be a person that's carrying a bomb or maybe some other target that's moving in the scene, and you have to identify frame by frame what is a threat and what is not a threat. And so this is typically a manual process where somebody sits there and draws areas of interest on the image and says, hey, this area here is concerning, this area here is not concerning. And a lot of that is outsourced internationally so that it can be done cheaply. But there's a whole host of problems with doing that. It still takes a very long time. It's labor intensive. It's costly.
Right.
And so he and his team have come up with some vast improvements in the area of video annotation, where they can very quickly apply annotations sequentially in a movie format that assist in this overall data annotation for big data purposes. And so, as you mentioned, they've launched recently, and they've got a product that's out there, and they're working and continue to improve upon it based on the feedback they're getting from some of the early adopters of the technology. And we're excited for Chris. Chris is excited, and Endoscopies is poised to do great things.
That's awesome. Yeah, Chris is a great guy. We've had a couple of different conversations, and I'm looking forward to his webcast.
He's a character.
Yeah.
He has a good radio voice too.
And he's also very into radios. So
yes.
That works out well.
Yeah.
So Becca, you want to talk about kind of where you guys are going? What can our network and those that are within my network do to help? What kinds of introductions or companies are you guys looking to have at this point in time in your journey?
Yeah. So ultimately, we're always looking for problems to solve. And sometimes we don't know that those problems exist until people bring them to our attention. And honestly, that's what we're looking for. We're looking to be able to solve problems that, keep people up at night. Obviously, if there are security professionals out there listening, or correctional officers, things like that, obviously there's ways that they can get in touch with us and we can work with them. We're always looking for partnering opportunities as well. So, someone that may offer technology that's complementary to ours, so that we can work together, generate more of that data, so that we can have more intelligence, more aggregate that data at a larger scale, to be able to analyze those trends better. So we're always, like I said, we're always looking for partnering opportunities. We're always looking for problems to solve. So that's how, essentially, if anyone's out there that thinks that they have a problem that can be solved with molecular chemical imaging, we're here to help.
Awesome. Well, anything else before we wrap up today? Anything that we missed? Anything that you're just itching to talk about from a ChemImage standpoint or a personal standpoint?
I think we covered a lot of ground. Appreciate the opportunity again. It's been a pleasure. If I can just echo some of what Becca had mentioned there, we're Pittsburgh is, as you know, becoming more and more of a technology city, and it's really booming right now. And Pittsburgh's leading that charge in for autonomy. And you got a lot of spin-outs coming out of CMU, and you got the autonomous vehicle. Everything is moving in that direction, and the things that ChemImage do is perfectly aligned with that. And as Becca mentioned, we're partner friendly. Join our journey. If you've got ideas, you got questions, contact us. We're happy to help. We're happy to discuss things. We'd love to have that discussion. And we're hiring. We're looking for talent and local talent in various fields. So check out our website and reach out to us.
Awesome. Matt, Becca, it's been an absolute pleasure. Thank you guys so much for joining me. Be on the lookout. I think this will be a good one. I think folks are going to enjoy it. So thanks for spending some time with me this evening.
Thanks, Alex.
Yeah, thank you.
All right.